This is Jacob's Algebra, Chapter 13, Lesson 2. Chapter 13 is all about quadratic equations. Remember, those are equations where our highest degree is 2, and we're going to be studying polynomial functions in this lesson. Mainly what we're going to be doing in this lesson is actually graphing. So remember, when you have a linear equations are first degree, like y equals x plus 5, or 2x plus 3y equals 7. These are linear equations. Our variables are present only in the first degree. Graphs of linear equations are always going to be a straight line. Quadratic equations are always going to be curved. So if we have 2x squared plus 3y equals 7, that's going to be a curve. 2x plus 3y equals 7, that's a straight line. Okay, so let's do some examples. So let's start with number 4. Number 4 says this exercise is about the function whose equation is y equals 2x plus 5. This is a linear equation. We know it's linear because x is first degree. So part A asks, what is the degree of this equation? It's a first degree equation because we have just the one x. X is to the first degree. Remember, if there's no power listed, it's understood to be 1. So when it says what is its degree, you can say first degree. Or you can say degree equals 1. Okay, part B asks what kind of function it is. Well, anytime you have a first degree equation, it is going to be linear. So you'll write linear for that part. Part C, what sort of graph does it have? Well, all linear equations have a straight line for their graph. So this answer is going to be straight line. And then part D gives you a table and says to copy and complete the table for the function. So I'm going to pause this and put this up on the board for you. Okay, so now you can see a data table. This is where I can plot out the points for our equation. While in the book it usually sets these up horizontally, I like to do them vertically like this. And the reason why is because it gives me room to actually work out what y equals. So if we start off with x equals -3 and our equation is y equals 2x plus 5, now we have room to actually work this out. What we're going to do is plug in -3 in place of the x. So we have 2 times -3, because this was 2x, plus 5. Now, what is 2 times -3? That's -6. And then we add 5. -6 plus 5 is going to be a -1. Sorry, that looks more like a 7. -1. Okay, so now we'll do the same for -2. 2 times -2 plus 5. That's -4 plus 5. And that's going to be a +1. 2 times -1 plus 5. That's going to equal -2 plus 5, which is 3. And we can continue on down our list. And what we will end up with is, for 0, we'll get 5. For 1, we'll get 7. For 2, we'll end up with 9. And for 3, we'll end up with 11. So those are going to be the values that we'll get when we actually plug our value in for x in the equation. So now then for part E, it says graph the function. Choose a suitable scale for the y-axis so you have room for all the points in your table. So what that means is once we've got our data table, we need to look at our x values, and we can see our x values range from -3 to 3. And we need to look at our y values, which range from -1 to 11. That means the top of our y-axis needs to go up as high as 11. And our x-axis needs to range at least from -3 to 3. So what I'm going to do now is pull up the graph I did. And let me make this bigger. So here is our graph. Put this down here where you can see it. Here is our graph of this equation. And you can see that what I did not mark all my points. I didn't label every single value for x and for y. I just labeled by 2's, but I did let each square on the graph equal 1. So 2 squares was 2, 2 squares was another 2, each square was just 1. And you can see that I have graphed the data points that we found. Over here where x equals -3, my y is -1. When our x was -2, our y was 1. When our x was 0, our y was 5. So this is what the graph is going to look like, and you can see it's a straight line, which is good because the graph for a linear equation should always be a straight line. Okay, so now we're going to move on. This was number 4, which is just like number 12 that I assigned for homework. So the next one we're going to do is number 5. Number 5 says this exercise is about the function whose equation is y equals x squared minus x. What is the degree of this equation? Remember, to find the degree of an equation, you need to find the highest power of a variable in the equation. In this equation, our highest power is 2. It's on our x. We have x to the second power. So the degree of this equation is second degree, or you could say the degree equals 2. Part B asks what kind of function it is. Well, if you remember in our last lesson, lesson 1, we learned that first degree equations are called linear, second degree equations are called quadratic. So this is a quadratic equation. Okay, part C asks what sort of graph it has. Well, linear graphs are straight lines, but quadratic graphs are curves. You're not going to get a straight line for a quadratic equation. And then part D says copy and complete the following table for this function. So I'm going to pause this and pop that up on the screen for you. Okay, so now you can see the data table for number 5, part D. And we need to figure out what our y values are given an x value. So they already told you which x values to use. We're going from -4 up to +4. And our equation is y equals x squared minus x. So what I'm going to be doing is plugging in this value that's given over here on the left into the equation in place of x. So I'm going to first use -4. So -4 squared, because I have x squared, minus -4 equals what? Well, -4 squared is going to be 16 because this negative is squared also. And the square of a negative is a positive. And when we subtract a negative number, that's the same as adding. So this is 16 plus 4, which is 20. So now I'm going to kind of start skipping some steps here. -3, when we square it, is going to become a +9. And then when we subtract a -3, that's adding 3. So this is going to be 12. -2, when we square it, becomes a +4. And then we're going to subtract a -2. Subtracting a -2 is the same as adding 2. So 4 plus 2 is 6. Now we're going to do -1. When we square a -1, we get a +1. And when we subtract a -1, that's the same as adding 1. Subtract a negative, that's the same as adding. 1 plus 1 is 2. So now we're going to use 0. 0 squared is 0. Minus 0 is going to be 0. And then for 1, 1 squared is 1. And then we're going to subtract 1. 1 minus 1, that's also 0. And then we'll use 2. 2 squared is 4. And then minus 2 is going to give us 2. 3 squared is 9. Minus 3 is 6. 4 squared is 16. Minus 4 is going to be 12. Now, I told you guys to watch out for one thing whenever you're doing making a data table. If you have two x values in a row that give you the same y value, then choose a number in between those two x values to compute a y value for. And the reason is so that you'll know what the graph is doing in between those two numbers, because you don't know if you have a straight line between those two numbers, or if the graph is going down, or if the graph is going up. So since I have the same y value for two x's in a row, I'm going to choose another x in between them. I'm going to choose x equals 1/2. So if I have 1/2 and I square it, and then I subtract 1/2, that's 1/4 minus 1/2, and that is -1/4. So if 1/2 is my x, then -1/4 is my y. So that is also a point on my graph. So now I'm going to pull up what the graph looks like for this problem. Okay, so here you can see 4e that we did already. This is 5e, if I can get it to slide over. So 5e, you can see this is our point that we just added here at the end at at positive 1/2. Our y value is about negative 1/4. I don't think I really show that that's about 1/4 very well here, but this is what your graph is going to look like. Let me slide this. Oh, I can't really. Let me make this a little bit smaller so that we can see this at the same time as our table. So there we go. So here you can see we have the point negative 4, 20. Well, here's negative 4 and 20 actually did not make it on my chart. Negative 3, 12. So here's negative 3 and a point up here at positive 12. Negative 2, 6. Here's negative 2, and you can see the point here at 6. We have negative 1, 2. So here's negative 1, and we have a point up here at 2. And then 0 is 0. That's right here. Our 1 was also 0. That's right here. And then for 2, our value was 2. If our x was 3, our y was 6. If our x was 4, our y was 12. Okay, so that was number 5, and it is just like number 13 that I assigned for homework. So let's move on and try another. Okay, so this was number 5, which was just like number 13 that I assigned for homework. Now let's look at number 6. Number 6 is another graphing problem. For number 6, you're told to graph the following functions all on one pair of axes. So these are all going to be graphed on top of each other. Let one unit on the y-axis represent 2. So each square in the y direction is going to represent 2 instead of just 1. And it says to make a table for each function before you try graphing them. So for 6a, we'll make an xy table. Let me draw my line here. So we'll do an xy table for 6a. And for 6a, our function that we have is y equals x squared. And then for 6b, we have another data table, and that is y equals x squared plus 6. And then for part C, we have x and y equals x squared minus 4, I think. Yes. So let me draw my lines here real quick, and we will make our data tables. Okay, so here we go. Okay, so what we're going to do is graph these from negative 4 to positive 4. So I'm going to do number 6a first. And for number 6a, if I let my x be a negative 4 when we square it is 16. Remember, when you square a negative number, you get a positive number. Then I'm going to do negative 2. Negative 2 squared is 4. 0 squared is 0. 2 squared is 4. And then I'm going to do 4 squared is 16. So now I'm going to use these same values of x for my other two equations. I have negative 4, negative 2, 0, 2, and 4, negative 4, negative 2, 0, 2, and 4. So I'm going to use the same values of x each time. Now remember, for graph A, we just did x squared. Graph B is x squared plus 6. Well, what that means is I'm going to take what I already calculated for x squared and just add 6 to it. So 16 plus 6, that's going to be 22. 4 plus 6, that's 10. 0 plus 6 is 6. 4 plus 6 is 10. And 16 plus 6 is 22 again. Okay, now we're going to look at our last one, y equals x squared minus 4. Again, I'm going to take my x squared value, and then I'm going to subtract 4. So 16 minus 4 is 12. 4 minus 4 is 0. 0 minus 4 is negative 4. 4 minus 4 is 0 again. And 16 minus 4 is 12. Whoops, sorry, I'm off the edge. And I will show how to graph these in the part 2 video.